This is Starring the Sun, a 2023 WPS SolarWise for Schools production. This material is based upon work supported by the National Science Foundation Award number 2000714. Any opinions, findings, and conclusions or recommendations expressed in this material are those of the author or authors and do not necessarily reflect the views of the National Science Foundation. Credit and thanks to nasa.gov for the use of nearly all of the photos used in this presentation. Of all the trillions upon trillions of stars in the observable universe, only one small and fairly unremarkable star really matters to us. It is our star, the star we call the Sun. Without it, life would be very different on planet Earth. Perhaps there would be no life at all. Because it is ours, the Sun is one of the most studied stars, but it is far from having revealed all of its secrets. Our Sun is a medium-sized star that dominates our solar system, a tiny part of the Milky Way galaxy. It is revealed here in extreme ultraviolet light. Differences in the Sun's densities cause the uneven appearance on its surface. Question 1. The uneven appearance of the surface of the Sun is caused by seeing a star's invisible light. Light provides us with information about objects in the universe. By studying extreme ultraviolet light from a star, we can study what it is made of. Though we cannot see ultraviolet light, we can capture it by letting a star's light pass through a filter and fall on a detector. Astronomers thus block the types of light from an object that they are not currently studying, just as a plastic foil filter limits the range of light through it. They direct the light onto an imaging detector, which detects types of light like UV to produce a picture of a star in UV light. At the right, the Sun is shown in different extreme ultraviolet light. Question 2. How can we study what a star is made of? Light and wavelengths. Light travels and behaves as waves. All light travels at a speed of about 300,000 kilometers per second, or about 186,000 miles a second. That means light can travel almost 8 times around the Earth in 1 second. There are many different kinds of light besides the one you can see, visible light. The entire range of different kinds of light, including the ones the human eye can't see, is called the electromagnetic spectrum. Scientists describe the differences between types of light, like visible and X-ray, in terms of length of the light's waves or wavelength. These types of light make up the electromagnetic spectrum. Wavelength is measured as the distance between the peaks or the lower points. Question 3. Light travels and behaves as? Question 4. All light travels at the speed of light, which is? Question 5. The entire range of different kinds of light, including the ones the human eye can't see, is called the? Question 6. Scientists describe the differences between types of light, like visible and X-ray, in terms of the length of the light's waves or? The electromagnetic spectrum. Scientists name the different regions of the electromagnetic spectrum according to their wavelengths. Radio waves have the longest wavelengths, up to thousands of kilometers. Microwaves range from a few centimeters to about 0.1 centimeters. Infrared radiation falls between 700 nanometers and 0.1 centimeters. Nanometers mean 1 billionth. Thus, 700 nanometers equals 700 billionths. Visible light is a very narrow band of radiation ranging from 400 to 700 nanometers. Ultraviolet light is a broader band below visible light, 10 and 300 nanometers. X-rays follow in the 100 billionth of a meter range. Gamma rays are even smaller. Question 7. Write each of the 7 different kinds of electromagnetic radiation into the proper box on your response guide. Earth's size in relation to the Sun. The black dot represents the approximate size of the Earth. The Sun is 865,000 miles in diameter, or 110 Earths across. Question 8. About how many Earths could fit across the diameter of the Sun? Real facts about the Sun. The Sun is 93 million miles from the Earth. Produces in 1 second the U.S. energy needs for 90,000 years. Sends its light to the Earth in 8 minutes. Consists of 92% hydrogen, 7% helium, and 1% other gases. Has an 11-year cycle of solar activity. Is 5 billion years old, another 5 billion to go. Is a medium-sized star, one of about 2 billion in our galaxy. Question 9. The Sun is how many miles from the Earth? Question 10. Every second, the Sun produces enough energy to handle the energy needs of the United States for how many years? Question 11. How long does it take light from the Sun to reach Earth? Question 12. The Sun consists mostly of these 2 elements. Provide the elements' names and their percent makeup of the Sun. Question 13. The Sun is how many years old? Question 14. The Sun will last how many more years? Question 15. If you drove a car at 100 miles per hour to the Sun, how many years would it take you to get there? Algebra and a calculator will be needed. The Sun is the source of all our energy. Every second, millions of protons in the Sun's core collide with other protons due to powerful pressures to produce helium nuclei in a fusion reaction that releases energy. The energy created by the extremely powerful fusion process in the Sun's core radiates out through the convection zone and eventually out into space. It takes a proton over 100,000 years to make this journey. Neutrons plus protons yield a helium nucleus plus light and energy. Without the Sun's heat and light, there would be no life on Earth. Question 16. The Sun is the source of how much of our energy? Question 17. The reaction shown in the slide, which takes place in the Sun's core, is called a blank reaction. Question 18. Complete the reaction started for you in your response guide. The solar corona. The corona is the area just above the surface. While the Sun's surface is about 5,000 degrees Celsius, the temperature in the corona reaches about 2 million degrees Celsius. What causes this rapid increase in temperature is not well understood. The corona can only be seen with special instruments or during a solar eclipse, when radiation from the Sun's surface is blocked by the Moon. Question 19. The temperature of the Sun's corona reaches about how many degrees Celsius? Sunspots. Darker and cooler areas on the Sun are caused by a concentration of the Sun's magnetic field lines which last from several hours to several months. Their frequency varies with the rise and fall of the solar cycle, which is 11 years. Question 20. Sunspots are caused by? Question 21. The frequency of sunspots varies with the rise and fall of a solar cycle, which is how many years in length? Solar flares from an active region. This photo captures the dynamics of a solar storm building up, then blasting a solar flare. Flares are small but intense explosions on the sun that propel high-energy protons into space. Question 22. What is a solar flare? Solar prominences. A common occurrence, these are eruptions caused by magnetic forces. Cooler gases above the photosphere can often be seen flowing along magnetic field lines. The sliding movement of gases follows the lines of magnetic forces. You can also see the boiling type of motion on the surface. The arrow points to an active region. Question 23. Solar prominences are caused by 2 coronal mass ejections, CMEs. CMEs are huge clouds of million-degree Celsius gases weighing billions of kilograms ejected from the sun at millions of kilometers per hour. CMEs are caused by the breaking apart of magnetic forces. Both CMEs seen here occurred within 20 hours and were headed towards Earth. With the sun's direct light blocked out, activity in the corona can be observed. Question 24. What is a coronal mass ejection? Question 25. What causes a CME? Earth's magnetosphere and a CME. Normal shape to the left, changed by a CME to the right. Electrically charged particles from a CME both compress and lengthen Earth's magnetosphere. The particles are guided by Earth's magnetic field lines, mostly from the far side into the polar regions. Question 26. What does a CME do to the Earth's magnetic field? When CMEs impact Earth. There are 5 pictures here: radiation danger for astronauts, spacecraft malfunctions, power system damage, which shows a fried transformer, communication disruptions, and navigational problems. These are some of the things that happen when a solar storm that we can't see with our eyes blows into our planet. In 1989, a CME knocked out Quebec's power for hours and interfered with navigational equipment and communication. Question 27. List 5 things that can happen when a CME impacts the Earth. What is the solar wind? A constant stream of particles flows out from the edges of large granules on the sun's surface. Picture 1. Solar wind is heated to about 1,000,000 degrees and travels about 450 kilometers per second. Picture 2. It pushes on and shapes the Earth's magnetosphere. Picture 3, and reaches out beyond Pluto's orbit, about 5,900 million kilometers away. Question 28. What is the solar wind? Auroral lights. Often called the northern or southern lights, these often colorful and flashing light displays in the night sky are mostly seen at high latitudes near the poles. They are caused by the impact of fast-moving electrons from outer space, our magnetosphere, on the Earth's upper atmosphere. Question 29. What causes the northern or southern lights, aurora borealis? Sun's effect on Earth's climate. Is the sun's variability tied to Earth's climate? Some scientists cite a correlation with droughts, small ice ages, and large-scale weather patterns on Earth. NOAA is doing research on this topic today. Latest research suggests that a small variability of the sun drives large-scale changes in weather. The small increase in solar radiation over the past 200 years might account for a significant part of our global warming. During the Little Ice Age, London's Thames River froze in winter in the 17th century. This engraving depicts the annual frost fair held on the icebound river in 1683 to 1684. This coincided with a period of very few sunspots and much lower than normal solar activity. Question 30. Research today suggests that large-scale changes in weather may be driven by what? The Solar and Heliospheric Observatory is a joint mission of NASA and the European Space Agency, ESA, to study the Sun for over 3 years. Has 12 instruments to study the Sun's interior, atmosphere, and solar wind. Provided most of the images and video in this presentation. Launched in December 1995. Make sure this assignment is well done and your name is on it. Delete the student lesson page before submitting. Credit and thanks go to nasa.gov for the use of nearly all of the photos used in this presentation. Starring the Sun, a 2023 WPS SolarWise for Schools presentation.